Namaskar. Good morning, everyone. Welcome to the Editorial Edge. Hello, Coder. Good morning. How are you? Good morning. Good morning. Welcome back. Firstly, today is the 30th. We are coming to the end of this month, and so there's a lot planned. Firstly, I'll be informing you of what all is planned as we come to the end of this month. But before that, before we begin this class, very quickly, can you see the screen behind me and you can hear me all right? Everything is okay, all systems okay. Then we can quickly jump into it. Okay, just let me know very quickly, please. If you're joining me live, just let me know very quickly because I have an interesting class ahead for you. Like I had mentioned, good morning Rajan, how are you? So like I had mentioned yesterday's class we took a deep dive in Chandrayaan 3. Today's class we'll take a deep dive in orbits. What are space orbits? Hi Madhusudan, good morning, welcome. Everything is okay, is everything okay guys? The screen, the setting, you can see everything, hear everything all right? Okay, fine. So we'll not delay much. So this is what is on my agenda today. First is what we are looking at is to discuss obviously the types of orbits in space. Now if you have followed yesterday's class on Chandrayaan 3, well I would suggest that you first watch Chandrayaan 3 lecture. Thereafter today, have a look at this. So that will essentially solidify your whole understanding. Okay, that will exactly tell you what you need to understand and from the exam perspective. All right. So pay attention in today's class. And then after that, in the second discussion, we'll take a look at a monkey, the talk macaque monkey, which thankfully is no more going to China now. The Chinese government wanted it imported from Sri Lanka. Cash-strapped Sri Lanka was supposed to send them 1,000 samples, units of the talk macaque monkey. The Chinese claimed it was for scientific research and that it would be in their zoos. But thankfully, that is not happening anymore after all the environmentalists went up in arms like, what are you doing? Okay. So that will be our second topic. So if any of you can figure out why I have a monkey in a space, let me know. Okay. If what's my logic behind putting in there, let me know. Meanwhile, this is my Telegram channel. Okay. Go ahead, sign up for the Telegram channel. Lots of informative content. In fact, last evening we did a video on a secret radio station. And that very idea came from the Telegram channel. Okay, so it's a place of learning, it's a place of interaction. Okay, go ahead, sign up, and you will see it will benefit you in the long run because again, all the PDF, all the material that we refer to, I make sure to upload it on that Telegram channel. Okay, all right. So let's jump into it, guys. The first one that we have today. But before I do, very quickly. So today is the 30th. Okay, the day that we begin this particular Prelims to interview initiative. This evening at 6 p.m. we close admissions for this finally. Today is your last chance to go ahead and sign up for the Prelims to interview initiative. An absolutely well thought out, scientifically enabled program that will enable any serious aspirant to gain that extra 10-15% that you need in your preparation, in your examination. Okay. So make sure that you sign up for this. It's a brilliant opportunity to be a part of something that is going to be holistic. You know, it's going to be comprehensive in enabling you to prepare well for the examination. So again, choose your language of delivery. Which language are you comfortable in? Hindi, English, or the bilingual one? Thereafter, use the code BALIVE and make sure that you avail for yourself a substantial discount. And this evening, 6 p.m., I shall see you. In fact, we all will see you here at StudyIQ as you will embark upon this journey for the next 1.5 years as to, you will go ahead and prepare in a manner in which it suits, it's befitting for the examination. Okay. That there is a method to the madness that will eventually follow. Okay. All right. So what are orbits, guys? You have been seeing these kind of animations, you have been seeing all of these since your childhood. So what is an orbit? First, you have to understand that it's a curved path. Okay, it's a curved path that a satellite or a spacefaring object takes around another object, and that is due to gravity. Obviously, you know that the only thing that is existing in space, obviously, is when you have two celestial bodies close to each other, or if one of them is bigger and the smaller one is there. So you have a gravitational interaction between the two celestial bodies. Okay, so objects of similar mass orbit each other with neither object at the center. So suppose if you have one body here, well, they will eventually be orbiting in somewhat this direction. They'll not be orbiting around each other, but in proximity of each other, while small objects orbit around larger objects. So like you have the Earth, all the planets, everything that we know in our solar system that orbits the sun. Hi Jyoti, how are you? Good morning, good morning. Okay. So the moon orbits the Earth, Earth orbits the sun, but that does not mean that the larger object remains completely still. So we might think that, you know what, sun at the middle is completely stagnant. That's not the case. In fact, what you will see is that because of gravity, Earth is pulled slightly from its center. You have these tidal movements that come and go because of the moon's gravitational force. Okay. Earth is pulled slightly through the center by the moon, whereas the sun is pulled slightly from its center by Earth and other planets. However, this is minuscule. Okay, this is quite negligible in fact. But that does not mean that it is not there. So this gravitational interaction between space bodies, celestial bodies, is very important for us to understand before we go ahead and dive into, say, what are orbits. Okay, what are the different types of orbits? Please understand that orbit, it does not mean that you have, say, always a bigger body and a smaller body. If in case two celestial bodies A and B are of similar mass, size, okay, they will be having this interaction of gravity, but that does not mean that one of them will be going around each other. No. All right. So just make a note of this. So this is obviously you know about how the whole solar system functions. Now let's go ahead. So how exactly are you going to achieve orbital height? Now please understand this. This is very crucial because then you will understand exactly why we do what we do. You know, what are geosynchronous orbits, you might ask me, or what are polar orbits, or what are transfer orbits. All of that comes from the basics first. Okay. So how do you achieve orbital height? Satellite is put into orbit by being placed hundreds or thousands of kilometers above Earth's surface. For example, now consider this. Good morning, Jyotirmay. Good morning, everyone. Consider this, guys. Suppose you are throwing a ball, okay? You are throwing a ball like this. What happens eventually? The curvature of the ball goes like this until it hits the ground. Why does that happen? Because the gravitational force is acting on the particular ball. Now imagine if you were to go right up at a great height, you know. So suppose if this is the Earth, you go at a great height. From there you now throw the ball, okay? And you throw the ball with a lot of force. So what happens eventually? This eventual thing where you are supposed to fall back on the surface of the Earth due to gravity, now because of the force, you have put yourself in a loop. See? This whole thing of going at a height and throwing it. Eventually, if the force of this is too high, rather than falling back towards the ground, you will go and get into an infinite loop around that particular body. That is what we do when we launch, say, spaceships or rocket ships. Okay. So satellite is put into orbit by being placed hundreds or thousands of kilometers above Earth's surface. You have the launch first, you take it to a certain height, okay, as if in a very tall tower, and then being given a push by the rocket's engines to make it start on its orbit. So have a look at this, guys. You will understand it clearly now. Yeah. See, ideally what would you expect when you throw the ball? That it would go ahead, fall back on the surface of the Earth. That is what would happen. However, you are going to a height, all right, and then you give this push, a massive push is given. So eventually what happens is, rather than falling this way, you start and go on a particular curvature around the Earth. An infinite loop you enter into. That is called orbital height. Okay. Please understand two words here. One is orbital height, and the other one, which we will do in the next slide, is called escape velocity. We'll do these two things. These are obviously physics concepts, but please understand why you need to know this, because you are going to use these in your words, in your answers. At the same time, from the prelims perspective, extremely critical for you to understand how does this actually work. Okay. So let's go back now. The difference is throwing something will make it fall on a curved path towards the ground. See, if I told you, if you just throw a ball, eventually it falls on the ground. Why does it fall on the ground? Gravitational force is higher than the force of your throw. Okay. But if you were to really throw the ball really hard and from a height, okay, the ground starts to curve away before your object reaches the ground. So see, if the ground is this way, if you have thrown from this height, eventually it curves away. Okay, and that's from a great height I'm telling you about. So your object will fall towards Earth indefinitely, causing it to circle the planet repeatedly. And in this case, congratulations, what you have done is you have reached orbital height. You have that now put that particular satellite or that object in the orbit of the Earth. This is what is done essentially, guys. Please be very clear in this first, the basic concepts. Okay? So you know that in space there is no air, no friction. So indefinite or infinite loop, thus application in communication, navigation, weather forecast, space observation, surveillance. Do you realize? Because something you don't have to fuel it. You don't need say particular energy source. Okay, you can rely on say solar panels also you can have. But more or less you are doing that because you have achieved the balance between the gravitational pull of the Earth as well as that at that particular height where it has gone into that loop. Do you realize? You're harnessing gravity for your own benefit. And so the applications of this are immense. Now you can straight away understand. If there is something that can go around my Earth, okay, either this way or this way, through the equator side or through the pole side, whichever way. Do you realize the applications of this? So for example, you must have seen photos of say glaciers. Old glaciers in 1960, the glacier was this big. You must have seen some photos. In 2023, the glacier is now this small. So how are you able to get these photos, guys? From that particular height, which means you have satellites that come and go at particular times, that chronicle that particular change on a say daily or a monthly or a weekly basis. So the applications of just knowing orbital height and how it functions gives you like a vast expanse of understanding now. You can use it anywhere. Okay, be clear here first. What are orbits? How do you achieve orbital height? Is that clear, guys? If that is clear, then let's enter into the choice of orbit. So like I told you, if this is Earth, okay, so now you have options. Either you can have something that is going to go from the pole side, say north to south orientation. One orbit can be like this. Or it can be something that can go from say this side, say west to east. So, east to west. Whichever way. Sorry, this is east, this is west. So west to east it can go. Or you can do it this way also. This way also. So you realize you can completely cover the Earth with satellites as well as have access to deep space missions if you exactly know what kind of orbit do I want to navigate first. Okay. So which orbit is chosen is depending on the mission objective now. So for example, if you are looking to go to the moon, there's a different type of orbit. Okay. If you are looking to say have a satellite for surveillance. Remember guys that movie Pokhran? John Abraham was there in that movie where they are making yes, it was in Pokhran only. That US satellite would come at a particular time, click a photo. The Indian army folks would quickly go and wrap up everything. Have you seen that movie, guys? Do you remember that? So you see the applications are manifold. From looking at glaciers to surveillance to telecommunication. Okay. All of that is depending on the orbits you choose. At the same time, you have these deep space telescopes, right? That look deep into the space. Give you say information that would ideally not be say used from here. You can't access that information here. So all that has different orbits. Do you realize? If you were to put in say if you're looking to look into the deep space, the dark space from Earth, you know that the Earth stands out as a blue ball. Have you seen that photos from NASA mission and all that? Where Earth completely in a dark room, it's like a blue ball is standing out. And then there is the massive bulb that is the sun. So if you are to go ahead and look at say deep space missions in so much of light, how will you? This essentially is what? That you are standing in front of the sun and hoping to click a picture of the sun. How will that function then? So what you need to do? You need to put your satellite in an orbit in which the light of this and the light of this can be negated. So we will show you what is called a Lagrange point, an L point. Another specific type of orbit where you put these deep space missions, telescopes and all of that, so that the Earth's own infrared radiation, the sun's radiation, all of that is negated out, so that it is amply dark in the space for you to have a look inside the space. Okay? We'll have a look at that. So two scenarios. First, the satellite orbits the Earth. Like I told you, first is obviously you are just looking at orbiting the Earth. So a different type of orbit will be needed. Second is that the satellite orbits the Sun, which means you are going on an interplanetary mission of sorts. So two types of scenarios we have. One is when you are just looking for local orbiting of the Earth, the applications I told you about. And second is when the satellite orbits the Sun, interplanetary missions before arriving at the final destination. Clear hai abhi tak? Shouldn't be very difficult. Very, very basic I have done so far. Now we go into the different types of orbits. First, let's look at the geostationary orbit. Now make a note of all of these guys. Obviously, I'll be sharing all of this on the Telegram channel. But make a note of this, okay? I'll tell you why. From the examination perspective, it is absolutely critical that you know all the different types of orbits, okay? What is the range? What is the usage? And more importantly, learn to correlate quickly. So if you see about a particular satellite from here on, know that straight away you should be able to tell me that, okay, this is the orbit it is operating in, okay? Know about International Space Station, which orbit is it operating in? Think from the practical point of view. We'll take a deep dive today, guys. Okay, it's 8:25. Next 30 minutes, it will be all clear. All right, geostationary orbit now. Satellites in the geostationary orbit, they circle the Earth above the equator. Have a look at this. I have a figure for you. Yes. See, they are going exactly along the equator. You see? Consistently along the equator. Now, if there is a person who is standing, say here, okay, at all times you will find that it's going to be fixed or ahead in front of you. You might get that appearance that the particular satellite is still, it's not moving. However, what's happening is that the speed of the satellite and speed of the Earth are same. The orientation of Earth and orientation of the satellite are also same. Okay. So have a look at this now. Satellites in geostationary orbit, they circle Earth above the equator. Okay. Direction is from west to east, just exactly as Earth's rotation. Time period is approximately 23 hours, something minutes, something seconds, in the 50s, okay. Approximately you can count it as 24 hours. Same speed as Earth, which is why they appear stationary in the sky. See? If the orientation and if the speed of both the parties, Earth and the satellite, is the same, to us here on the planet, we are going to look at it and think, oh, it's not moving. Relative speed, you realize that? Relative speed sabne padha hai. This is what's happening here. They both are moving together at the same time. Okay? So, primarily used by telecommunication, weather forecasting satellites. And now look at this. Since they are at a height, so if this is the Earth, your GEO, okay, it's going to be at a height. Huge height. So what happens now? If you have a huge height, you are going to cover more area. Look at this. Right? You are essentially looking at what? Boxing the whole Earth through 3 of these at great height. The higher you go, the more angle of exposure you have. Simple maths. Remember? Good morning, Bulbul. Welcome all of you. Do you understand that? So, if you have 3 of these satellites, say one here, the second one here, and the third one here. With these 3 of satellites equally spaced, you can cover the whole surface of the Earth. You know, tracking the surface of the Earth. Why would this be important? Now tell me, guys. Why would this be important? Firstly, what you are looking at is these are going to be at great height, which means they are going to give you a macro focus of what's happening down below. Your weather patterns, your telecommunications. Do you realize weather forecasting nowadays has improved? Why? Because we are able to better monitor. Okay. Why do you think most of the spacefaring agencies suddenly want to send their weather forecasting satellites? Because again, it's directly linked to your economy, your agriculture, your people. So for that, you go and invest in something like this to get that information beforehand. Okay, clear? So this is a geostationary satellite. Again, make a note of these two things because from the prelims perspective, this is the factual knowledge that you ought to know. Good morning all of you. Welcome. Are you able to understand, guys? If yes, just let me know in the chat very quickly. If there is any doubt, don't harbor it right now. Okay. This is very easy to understand. And if you understand this, you will understand the thought process that goes behind, say, a particular mission. Let me know very quickly in the chat. If you're following what I'm saying, just write yes or whatever. Just write yes. Quickly, very quickly. All right. So that is a geostationary satellite or an orbit. Clear? Let's look at an LEO now. Low Earth orbit. Okay. Take low Earth orbit. So an altitude of between 160 to 1000 kilometers. ठीक है? Okay. Fine. Good enough. ठीक है. Thanks guys. Thank you. So in low Earth orbit now. So obviously by the name itself you understand that the satellite's altitude is much lower. Now the GEO1, you are looking at a height of roughly say 36,000 kilometers. Okay. So it's going to be really high up there. But in these ones, you are looking at a very minimal height. 160 to 1000 kilometers only. Now bear in mind that the aircraft that we fly in, it does not go higher than say 13 kilometers at most. Okay. And in fact, this line, no, so you must understand, this line as to where does say Earth finish and space begin. You know, so there is a line called the Kármán line. Make a note of this too. The Kármán line, which essentially says that at 100 kilometers and beyond is space. Again, this is disputed, not universally accepted. But for the purpose of our understanding, let's just understand Kármán line first. 100 kilometers के आसपास. ठीक है? So altitude of satellite, you're looking at 160 kilometers to 1000 kilometers. Now, unlike GEO, LEO satellites do not have to follow a particular path. Their plane can be tilted. Very crucial, guys. That it is not, say, having to go along the equator only. Because that's the major difference, no? In GEO, you are looking at only along the equator. Whereas in LEO, they can go through any plane. Now look at this. Any way you can just circumnavigate the Earth. Any way, if you can just wrap around the satellite around the Earth at a height of 160 to 1000 kilometers, LEO. Clear che? Understand this. It is not again just equator wise, no boundaries here. You can do it whichever way possible because again the plane is tilted, right? So please understand the applications of this now. So you have more available routes. If you are not just going through the equator, along the equator, if you can wrap the Earth through any plane, n number of routes can come up. You have the direction, the orientation, the speed, the height, altitude. You can find any n number of variations now. Permutation combination. Okay? So, thus more routes for satellites in the low Earth orbit, which is one of the reasons why LEO is a very commonly used orbit. All of these academic missions, college students sending satellites, you must have heard. Okay? You must have heard of, say, particular agencies that send or private bodies that send their satellites. Most of these satellites go in the LEO, the low Earth orbit. Okay. So due to close proximity, orbit most commonly used for satellite imaging. In fact, you had a satellite called KH-12. I was reading about this last evening itself, so I thought I should tell you this. So that Pokhran movie, where the Americans come, take a picture of it, okay, are the Indians up to, are the Indians making their nuclear weapons? And John Abraham, Abdul Kalam Sahab, the whole acting group will quickly go ahead and make it as if nothing is happening. So that satellite that used to come, the American spy satellite, that was called KH-12, and it was in low Earth orbit. So why it was in the low Earth orbit is quite clear to you now. Because you're looking at imaging. taking high resolution photos of a particular area. Surveillance. Do you realize that? So low Earth orbit is critical for you to understand. Okay. The ISS also in this orbit. Now please understand, why should the ISS be in the LEO? Because again, if you're doing multiple trips up and down, if it is at a great height, more money. Do you realize? You need to be at a height where it is financially feasible for you. Most of the practicality is around money. Hi Lekam, sorry I missed your names. Good morning all of you, good morning. Okay. So ISS is also in the LEO. Why? Because again, you need it to be at just a bare minimum height. It's going to be basically for space observation, no? Okay. 90 minutes to circle the Earth, which means the ISS circles the Earth 16 times a day. Obviously, if you are at a smaller height, okay, if you are at a smaller height and if you are at a bigger height, here you are going to take a larger circle, more time. If you are at a smaller height, you can quickly go around, no? We have discussed this yesterday. The higher you go, the slower you become. The lower you are, the faster you go. Because you have to break free from the Earth's gravity also. The escape velocity, we'll discuss what is escape velocity. Okay? Alright. Communications satellites use constellation. Now what happens is, see the speed that I told you, no? Wait, let me clear this first. So now you suppose if the satellite is going at this particular, suppose, okay? If this is the one and if it is at this height, so it's going at a great speed because with altitude, your speed goes down. So if the altitude is low right now, which means the speed is high, so if the satellite is going faster, for communication satellites, one major thing is that you require is, for communication satellites, what you need to do is track them. Okay? You need to track them so that you are able to maintain that communication link. However, if the satellite is going too fast, what happens is the on-ground tracking system does not work. So what's the way around it? You have multiple of them. Okay, multiple of them. A constellation, you are basically making a web. So communication satellites use a constellation of like to form a web and then put it in the LEO. In spite of the high speed, they are able to be used for communication linking. समझ में आ रहा है? So a constellation, communication satellites, they use a constellation. Make a note of this. Constellation is basically to make a network of satellites, okay, which can be used effectively for communication. Clear? All right. So that was low Earth orbit. Now let's look at polar orbit and sun synchronous orbit. Very, very easy to understand. Okay, naam khali difficult hai. Concept is very easy. So in polar orbits, satellite will move from north to south. Self-explanatory. Polar orbit, which means they are coming along the poles. So they move from north to south rather than west to east. Okay. Type of low Earth orbit, again, same range. LEO was roughly what, 160 to 1000? More or less, polar orbits are also the same range, 200 to 1000. Now, sun synchronous orbits are a type of polar orbit. So you have to understand this. LEO, which has polar orbit, out of which comes the sun synchronous orbit. This is the relationship first. Understand this first. Okay. So now, sun synchronous orbits are a type of polar orbit. They are synchronized to always be in the same fixed position relative to the sun. Okay. We'll see. I'll show you. Which means that the satellite always visits the same spot at the same local time. Why do you need this, guys? Look at this. See? Look at this. It is essentially what? The Earth is moving west to east, right? If your satellite is moving north to south, what happens? As the speed moves this way, and if you come this way, you are going to have that moment of convergence at the same time every day, local time obviously. The usages of this you can straight away imagine. Massive surveillance you can do. Not just surveillance, looking at environmental changes. How a particular place, how a particular body is changing over time. All of these photos that you see, no, of massive deforestation that has taken place in 60s, 70s, 80s. Riverbeds drying up, glacial melts losing, all of that can be tracked through the sun synchronous orbit. So have a look at this now. So satellite visits the same spot at the same local time. For example, passing Pokhran every day at noon exactly. You will understand now what was happening. Okay. Satellite images can compare how somewhere something changes over time. Okay. Sun synchronous orbit, if you know this relationship, guys, that it is a subset of polar orbit, which itself is a subset of low Earth orbit. That it is a sun synchronous orbit wherein you are coming from north to south, the Earth is going from west to east. The moment of convergence between these two actions, make sure that you are there at that particular place every day at the same time. Do you understand that? So now you understand what was happening in Pokhran. Low Earth orbit, something that was sun synchronous, used for surveillance purposes. Clear now? Now it will make sense to you. Okay. Did I miss anything in this? No. Okay. And then finally we look at transfer orbits and geostationary transfer orbits. Now this is important for us to understand from the Chandrayaan 3 perspective. Chandrayaan, sorry. Okay. Very important for us to understand this because this is what we are going to use in the C3 project. So transfer orbit, we're using relatively little energy from built-in motors. The satellite or spacecraft can move from one orbit to another. Yesterday I told you, how you go ahead and elevate the height slowly, so that you can escape the Earth's gravitational field. Look at this, guys. This is what happens. You launch and you go ahead slowly, increasing the height until you reach that height where you can escape the Earth and move forward in your journey. This particular speed at which it goes needs to go to escape the Earth's gravitational field is called escape velocity. Okay. Escape velocity. Because eventually what? The Earth also has a gravitational pull, no? The satellite needs to escape that, or else it will be always in the net of the Earth. So you need to go at a particular speed until you finally are going at fast enough to escape Earth's gravitational field and finally go into the interplanetary journey that you're hoping to go. Okay, so let's look at this. This allows the satellite to reach, for example, high altitude orbit without needing the launch vehicle to go all the way. So all these GSLV and all that we send, straight away what happens is you do not take them up to that great height, to that GEO limit, to the GEO limit. To that great height, if you have to take, you'll have to burn a lot of fuel. Not possible. Your payload will be too heavy, too limited then. You'll only be carrying fuel. So what do? You go to a certain height. Then after that, use the energy motors to just take up. Every time you just go little higher. Every time you go little higher. Okay. Go ahead, go around the Earth once, little higher. Go around the Earth again, little higher. All of that you're doing how? Essentially to escape the Earth's gravitational field. So this, say first level you went, then second level you went, then third level you went, height-wise if I'm saying, if this is the Earth. So this becomes a transfer orbit. You're transferring yourself from orbit to orbit higher. Okay? Reaching GEO in this way is an example of one of the most common transfer orbits called the geostationary transfer orbit, the GTO. Okay, let's look at the GTO now. So after liftoff, a launch vehicle makes its way to the space following a path shown by the yellow line. So look at this now. Very clearly we'll look at it so that आपको याद रहेगा. So this is where a launch vehicle has taken. If you have seen, say, NASA launch videos, ISRO launch videos, you must have always noticed that it takes off and it does not go like this straight away. You will see that it goes little in a straight line and eventually starts curving. So the uninformed will think, अरे गिर रहा है क्या? नहीं, वो नहीं गिर रहा है. It is meant to go that way. If it goes straight, then you're burning more energy. At the same time, you're fighting more gravity. Gravity is acting directly at it. So how do you start to negate it? Go on a curved path. This is what happens, guys. Okay. Launch vehicle makes its way in a curved path At the target destination, the rocket releases the payload which sets off an elliptical orbit. See, this elliptical orbit you go into, this blue line that you see here. Okay. Following the blue line which sends the payload farther away from Earth. So what you have done is you have gone ahead to a certain height. Thereafter, you have entered this transfer orbit. Yes, Rajan Kumar, I remember. But see now, if you can correlate this, if you can see this now, and go see any space movie, you will understand exactly what they are talking about. The technical terms, oh, we are in problem in transfer orbit, L1, L2. They'll be discussing all of that. Now it will be like, अच्छा ये बात कर रही है. ठीक है? The point farthest away from the Earth on the blue elliptical path is called apogee. Point closest is called perigee. You know this. This is NCERT level. Nothing to explain here. Okay, this is exact NCERT. This is in fact a line from the NCERT I have taken. Okay. So once you have done this, you have reached 36,000 kilometers. Okay. Then you go ahead and escape the Earth's gravitational field. Clear? You have to be absolutely clear in this, guys. Okay. And the final one we come to is the Lagrange point. L point they are called. So all of these deep space telescope. First look at this, then you will understand exactly what I'm talking to you about. So this is the Earth. Can you see this clearly? See how it is forming a spiral, and you have the sun here. So if you need to start observing this way in deep space, you need an area of shade. Now look how that area of shade is being formed, guys. See it again. It's important for you to understand is that area of shade that is being formed vis-a-vis the sun and the Earth. That shade area is essentially going to enable you to look into space. Because if you were looking with the sun in your backdrop or sun in front of you, it's like trying to look into the sun. आपका आँख ही नहीं खुलेगा उधर. समझिएगा ही नहीं कि करना क्या है. So you need an area of shade, which is why you go behind the Earth and find a point where it is sun and the Earth are in straight line, and then you look in the shade area so that you are able to find out, acha, this is what is happening in deep space. Clear? Have a look at this very clearly. I am going to share this PDF as well as PPT so that all these GIFs that I have taken from the European Space Agency website, you will be able to see it in your own personal laptops, computers. Okay? Because what happens is for space technologies, no, just showing photos is not enough. Even I learned through videos, I learned through GIFs, I learned through animation, which is why I try to do this. I tried bringing in this in the class today. Is it informative, guys? Are you understanding? So let's look at L point now. So for many spacecraft being put in orbit, being too close to the Earth can be disruptive. Okay? Why? Because for space-based observatories, if you are going to photograph deep space, you know that the Earth emits visible light and infrared radiation. Make a note of this. We will do this from the MCQ perspective as to what are the kind of different bands or the wavelengths of light that Earth emits. We will do that. Okay, this is a possible question from Prelims perspective. Okay. So Lagrange points or L points allow for orbits that are much, much farther away and do not orbit Earth directly. They will form their own local orbit there. However, their direction and orientation will be such that they will mean that shade area. They will be able to look dark into the deep dark space without the brightness of the Earth and the sun coming into the picture. Okay. So there are specific points far out in space where the gravitational fields of Earth and the sun are balanced, that orbit them remaining stable and thus can be anchored relative to Earth. So you have both of the gravitational field of the Earth, the sun. You find that point where it is exactly balanced, which allows them to locally orbit, at the same time be in the shade area. Go ahead, look into space. All of these things we'll talk about, no, that some supernova explosion happened in some other, what is it called? System, Milky Way equivalent. How do we know that? You can't have that information sitting on the Earth because there's too much of light that we emit. Do you understand that? Adarsh, why spacecraft are mainly launched from the equator? Like I told you, no, Adarsh. So if you are doing it from the equator firstly, what you are looking at is essentially to go into the transfer orbit very quickly. Okay. And in fact, you raise a very good question. What you will see is that our whatever we launch, no, suppose if this is the Indian landmass. So if we're launching from here, most of it is in this direction. It goes southwards and then enters. Okay. You are looking at it why from 2-3 perspective. If the mission was not to be successful, you don't want it to be falling on a particular populated area. So you have the vast Indian Ocean that is there, which allows for, say, no problems for other countries, no liabilities as such. At the same time, easier for you to go into the transfer orbit. Okay. It's a very interesting concept, guys, and make sure that you go through this whole PDF again. PPT only I'll put up. PDF में तो आपको GIF दिखेगा नहीं. PPT I will put up. Have a look at it. It will be in my Telegram channel. I'll upload it at 12. All right. Okay. So that is it. That brings to the end of orbits. Now, if you have any doubts, any questions, quickly shoot them. I will be addressing all of the doubts and the questions. However, make sure that you first go through the whole discussion now. Go through the animation that is there. Of course, yes, Nalajana, that's true, no? Equator, you have less gravitational force. You are looking to quickly escape the field of the earth, no? That is the whole point. Use less resources, less energy, more payload. For that, give yourself every advantage that you can. Samajh rahe ho, Adarsh? If possible, please do make sure that you come on the Telegram channel. We do a lot of informative work. Okay. In fact, I don't think I have put even one motivational quote so far. I don't like motivational quotes too much. Anyways, so this, guys, is ending today evening, 30th. Today is the day, which is why I made sure I had to tell you this, that an opportunity should not be lost, especially if you are unable to join us for the P2I, the Prelims to Initiative, interview initiative. Go ahead and join us for the CSAT initiative. Okay. Most likely, I will be a part of this whole program. I will be taking care of the reading comprehension. And if you want, say, a demo video of what I have taught or how I teach, go on to the StudyIQ English website. Under the playlists, you will find an entire series on RC, reading comprehension, that I had done just prior to the prelims this year. Also, go on to the StudyIQ website, the YouTube channel, and the discussion that we did just after CSAT. That very evening we had done. Go ahead and have a look at how we approached the questions, guys. Okay. There's a certain way you need to prepare yourself for the CSAT paper, and that will be best served if you come ahead, Go ahead and join this. Be live. Please use this, because essentially this is what enables me to be a part of your preparation. The classes will be beginning today itself. I think 3 p.m. 3 p.m. we begin today. 3:30. Adarsh, link of the channel, StudyIQ English, the one that you're watching it on, इसी में आपको मिल जाएगा. या फिर you just search for StudyIQ and just search CSAT discussion. It'll show up. I and Ankit sir had done it on the 28th evening, and so you have a look at that, how we approached CSAT. It's one of the most well thought out series, actually, I can say you. If हमारे time पे होता, कितना help होता हम लोग को. ठीक है. Anyways. So now we come to this cute looking monkey. Okay, this cute looking monkey that the Chinese wanted for themselves. Adarsh, I'll just show you my Telegram. Give me a second, please. Let's just finish this first. Okay, let's look at this cute looking monkey and why the Chinese suddenly wanted 1,000 of them to be sent to China. And they obviously were getting it from Sri Lanka. Now, Sri Lanka is under debt, massive problem. And they owe money, sorrowfully, to China. So China went ahead, said, send these cute looking creatures, 1,000 of them. Sri Lanka almost agreed. Then came the environmentalists, and basically Sri Lanka had to back down. That is not the story. That is not much importance for us. That is the background as to why we are discussing this news. But let's look at the toque macaque monkey. Okay, very, very important again, because it is an endangered species under IUCN, is in the news. So as UPSC aspirants, you will be best advised to at least be aware of it. Okay. So it's an old world monkey endemic to Sri Lanka. What is an old world monkey first? Please understand that. Forget environment, okay. What do you understand by old world and new world? Think of that first. Come to the basics. You know that old world, whenever we read history, it is always referred to the continents of Asia, Africa, Europe. Are you aware of this? That old world is to do with Asia, Africa and Europe. Whereas you must have read that new world is to do with America. पता है ना ये? नहीं पता है तो लिख लीजिए. So old world is essentially to do with us, Asia, Africa, Europe. New world found much later, Americas. Now the monkeys found in these areas, old world monkey, new world monkey. First things first. Endemic, matlab found specifically in Sri Lanka. Okay, local to that area. Now common talk macaque, pale fronted macaque and hill zone macaque. They are the three subsets of the talk macaque monkey. Okay. Three subsets, names are quite easy. The common one is found in the dry habitat. The pale fronted one is found in the wet areas. The hill one in the hilly areas. Okay. Now, the characteristic feature is the talk-like swirl of the hair. You see this hair here, which is why I called it cute. Look at this. So, it will have this hair that will be like, like a crown type it will be having. Okay. So, that is the feature. The talk-like swirl of the hair, which is why it is called talk macaque monkey. Okay. They have a long tail relative to their body size, and in fact, they are a monkey group that follows hierarchy a lot. So you have an alpha male. Okay. You have an alpha male who has a group of henchmen. Like, how villains in Hindi movies have these 5. One of them will be a bald guy, one of them will be a foreigner. Have you seen old Hindi movies? The villain has 5 henchmen, उसका बंधा होता था, एक गंजा होगा, एक foreigner होगा. So all of that is there. The alpha will have his henchmen, and the hierarchy is extensively followed. They are a very hierarchical group. ठीक है? So the talk macaque monkey. Now just quickly understand the difference between old world monkeys and new world monkeys from the examination point of view. You know now that old world monkeys are to do with the monkeys that are found in Asia, Europe, Africa. New world monkeys to do with Americas. Okay. Old world monkey, Africa, Asia. New world monkey, Americas. All of these are different, the differences between the two. However, one thing that you need to be really aware of is, I'll tell you which one. Yes, the habitat. So the old world, the ones that are here in our place, you will see that the habitat is mostly on the ground, whereas the new world, they will be arboreal, which means on the trees. Arboreal animals are what? What are arboreal animals? Animals that are found or live or sustain themselves on the trees. Okay. Again, an important question from the UPSC perspective. Which of the following are a group of arboreal animals? You will find 4 animals into 4 options. 16 animal honge total. So you need to know which are found on trees, which are not found on trees. So if you found, say, a option there that says old world monkey, you can be absolutely sure that that is not an arboreal. The new world monkeys are. Another difference I'll tell you. If you have, say, observed monkeys in your own neighborhood, you will find that the baby monkey, if this is the mother monkey, suppose this is the mother monkey, the baby monkey will be below her. Okay, the baby monkey will be here. The monkey is below, holding on to the mother from the ground up, face up. Have you seen that? But in terms of new world monkey, the baby does not come below the mother. The baby comes on the back of the mother. Minor differences. As UPSC aspirants, best advised to at least make a note of it. Observe around yourself, guys. Why is that certain monkeys hold on to their mothers from down? Why is it that certain monkeys are holding on to their mothers from above? Difference. New world monkey, old world monkey. Next time you go ahead and see a documentary where you see that the baby is hanging on to the mother from above, you will straight away know that that's a new world monkey. Can't be an old world monkey. Okay. Is it clear, guys? Okay. Then you have other problems also. So one has molars, one does not have molars. You can have a look at that. Those are very specific things. Just make a note of it. If you eventually make a note of it, it will come to you naturally. Talk macaque monkey. Clear hai sabko? Clear, everyone? All right. So that brings to the end this deep dive into orbits. We discussed 7 types of orbits. If it was little overwhelming, don't worry. After the class ends, go ahead, I'll share the PDF, have a look at it again. In fact, look at it in the PPT format so that you can see all the GIF that I've shared. If you have any doubts, reach out to me on this email ID. Okay, I'll be more than happy to take doubts because I know doubts aayenge isme. This is a topic that is little confusing, but once you get the hang of it, it's most easy. Okay. If you have any doubts, reach out to me on bhuvan.jha@studyiq.com. All right. And this is my Telegram channel. This is where we do all the brainstorming. In fact, I learn more from the students there. A simple poll told me a video that I did last evening on the secret radio station in Goa. So most of you, again, most of the class thought that it was to do with the Congress radio under Usha Mehta, the secret radio that was there. However, there exists other radio stations also, post-independence also, that helped in the, say, the story of India. So again, we do a lot of brainstorming, a lot of ideas I get just from the responses of my dear students on that group. So go ahead, be a part of that group and avail for yourself a very comprehensive opportunity to understand topics not in isolation but as a part of a bigger frame. Okay. As civil service aspirants, that's what you're expected to do. Anjali, don't worry. So you can, in fact, you don't need to worry if you were late for this session. After the session ends, it will be there on YouTube. You can quickly just play it from the very beginning. And before you guys I take leave of you, please may I request you, I request you to like the stream for me. There's a lot of hard work that I have to do to prepare these slides. You must have understood, It requires extensive research, figuring out the kind of animation I want to use, because this is the biggest advantage of this platform. That there is no chalk and blackboard, so I can use a lot of methods at my disposal to get my message across. So if you like this video, if it was informative to you, please may I request you, go ahead, firstly do 2 things for me. 1, like this stream, and 2, be a part of this Telegram channel. Okay guys? Alright, on that note, it's a wrap for today. Today in fact we did not do not even half of what I had planned to do in terms of editorial, which is why tomorrow's class we will do extensively in the news. Today was a follow-up class of yesterday where we discussed Chandrayaan 3. That brings to an end the space segment that we have done for the last 2 days. One more is left, which is the legal framework as to what space is. Does it belong to the mankind? Can it be used for common good? That we will discuss some other day. Maybe next month when Chandrayaan is getting launched, we will take a look at the legal framework insofar as outer space is concerned. But the building blocks are in place. The space segment over the last 2 days is over and is finished now, done. Okay? Alright, thank you. Thank you, Coder. Thank you, Adarsh Bhai. Rajan, thank you so much. All of you, thank you for joining. And I shall see you all tomorrow morning, same time, 8 AM. Thank you once again for joining. Stay safe, study well, and go through this PPT that I'll share on the Telegram channel. Okay? Bye guys.